Hey class, so this is how does a catalyst affect a reaction rate? So take a look at catalysts. This is 14.7, notes 14.7. Catalysts increase the reaction rate by decreasing the activation energy. So this is the important part here, decreasing the activation energy. Take a look at my diagram down below. Notice that if I include a catalyst, then it takes a different path. Without a catalyst, I have a huge activation energy here that takes a lot of energy to get this reaction started. Up here is where you see the difference between the energy of the reactants and how high it has to go. So a catalyst helps change the amount of energy that's needed. Sometimes it goes up only this far and then gives off some energy, which then helps it complete the rest of the path. Still a lot lower activation energy than compared to what it was beforehand without uncatalyzed. So when you decrease the activation energy, you increase the chances that the molecules are going to react properly the way they should. And that's why catalysts work so well. So let's take a quick look at some cases for catalysts. There are some things called well, there are two different types of catalysts. There are catalysts that are what we call heterogeneous catalysts. And those work by providing a place or an environment for a reaction to take place. Notice I got like hydrogen and a hydrocarbon here. Hydrocarbon having, looks like C2H4. Ethene, and then they provide a site then for the reaction to take place. Otherwise, the reaction would be, it would take too long for the two molecules to find each other. So after this, by the way, this is platinum. Platinum is an excellent organic chemistry catalyst because it provides a site for the reaction to happen, and that reaction happens a lot quicker because of it. So it takes away some of the uncertainty. That's just one type, heterogeneous catalyst. My example for that is what you're looking at below, which would of course be platinum. So you have things that are in different states, and that's the heterogeneous part of the catalyst. So things that are in the same state, of course, would be homogeneous catalyst. Here's an example, a biochemical example of enzymes. I'm sure you've heard of this previously in one of the honors biology classes or some other class. Where they talk about the enzymes. What does an enzyme do? An enzyme is a place, this would be a heterogeneous catalyst, which is a place where specific substrates or specific molecules can fit into the enzyme, and then they break apart or they do whatever they need to do. So as providing a place, this would be a heterogeneous catalyst. Okay, the substrate fits into the active site of the environment of the enzyme, much like a key fits into a lock. So it catalyzes specific reactions for the body. Take a look at this. It says what a catalyst looks like in elementary steps. So here I have two elementary steps. This, of course, would be step 1 and step 2 of the same reaction. Notice I'm starting off with NO and N2O, and then that changes to N2 plus NO2. And then I have 2 NO2 from this reaction here, 2 NO2 that change into 2NO plus O2. Now, these all compounds all look the same, but I'm going to point out, number 1, an intermediate, and how that's different from a catalyst. So catalyst starts and finishes the reaction looking exactly the same. And we have that here. We have nitrogen monoxide and nitrogen monoxide showing up in both the reactants on one side and the products on the other. And because these two are the same, this is our catalyst. Okay? The catalyst shows up in the beginning and at the end unchanged, even though it may actually go through the equation and change a little bit, but then it changes back. Okay, so this helps to lower the activation energy. Now we do have an intermediate. What's an intermediate? An intermediate is something that is produced and then used up again. and that would be our NO2. Notice we have an NO2 here, and we have an NO2 here. And the NO2 gets used up, which means that it's an intermediate. So this is the difference between a catalyst, the NO, and an intermediate, NO2. And that's important to know. All right. Thanks for paying attention to Notes 14.7.